Welcome to exploration of basic mathematics.
Trigonometry. Part 6. Sine, cosine. Of sum of angles. We will be learning sine, cosine and tangent of two angles alpha and beta. We will be also learning derivation of double angle formulas, that is sine of 2 alpha, and half angle formulas, that is sine of half alpha. Before we start, we recollect some basics to get into trigonometry.
The triangle. A triangle is a closed-shaped figure in a plane with 3 angles, 3 sides, and 3 vertices. Three vertices are A, B, C. Sides are side AB or C, side AC or B, and side BC or A. Angles are angle AE or angle CAB, angle B or angle ABC, angle C or angle ACB. Right-angled triangle. In a right-angled triangle, one angle is right angle, that is 90 degrees, as sum of all angles in a triangle is 180 degrees, so other two angles, angle A and angle B, add up to 90 degrees. Angle A and angle B are complementary, or angles A equals 90 degrees minus angle B. To draw a specific right-angled triangle, one must know at least one side of the triangle, along with angle A. Of 3 sides of a right-angled triangle, the opposite side to right angle is always the longest side, and it is called hypotenuse. Other 2 sides are opposite and adjacent to angle A. Please note, but for angle B, the opposite and the adjacent are interchanged. The side CA is opposite, and the side BC is adjacent to angle B. In any right-angled triangle with 3 sides known, can we calculate values of angles? Using trigonometry and its function, one can relate sides with angles. Trigonometrical ratios are sine, cosine, and tangent. In short, we write them as sine, cos, and tan, and are defined as sine A equals opposite, divided by hypotenuse. Cosine A equals adjacent, divided by hypotenuse. And tangent A equals opposite, divided by adjacent. With the help of sine, cosine, and tangent, any side of the right-angled triangle, adjacent, opposite, and hypotenuse can be calculated using following form. Opposite equals hypotenuse multiplied by sine A. Adjacent equals hypotenuse multiplied by cos A. Opposite equals adjacent multiplied by tan A. Trigonometrical ratios of complementary angles. Sine of A equals cosine of B. In cosine, the prefix co is for complementary. It means that the ratio of the angle is equal to the co-ratio of the complementary angle. Also, we define here trigonometrical ratios of another complementary angles, cotangent or cot, as cot A equals adjacent, divided by opposite, or B divided by A. Tangent or tan A equals cotangent or cot B. There are 6 possible ratios and are defined as opposite divided by hypotenuse equals sine A, adjacent divided by hypotenuse equals cosine A. Opposite divided by adjacent equals tangent or tan. Adjacent divided by opposite equals cotangent or cot A. Hypotenuse divided by adjacent equals sec A. Hypotenuse dot divided by opposite equals cosec A. These ratios are also related as sine A equals 1 divided by cosec A. Cos A equals 1 divided by sec A. Tan A equals 1 divided by cot A. Sine, cosine of sum of angles. Now we learn sine, cosine of sum of angles. Draw first an angle alpha at a vertex O on line OA. The angle AOB is angle alpha. Draw another angle, angle beta, at same vertex O. On the line OB, the angle BOC is angle beta, and the angle AOC is angle alpha plus beta. Choose a point P on the angle arm OC and drop a perpendiculars PM on the line OA. Note in the triangle OPM, angle POM is angle alpha plus beta. So the sine of alpha plus beta equals PM divided by OP, and the cos of alpha plus beta equals OM divided by OP. From the same point P, drop a next perpendiculars PL on the line OB. Note in the triangle OPL, angle POL is angle beta. So the sine of beta equals PL divided by OP, and the cos of beta equals OL divided by OP. From the point L, drop another perpendiculars NL on the line OA. Note in triangle ONL, the angle ONL is angle alpha. So the sine of alpha equals NL divided by OL, and the cos of alpha equals NO divided by OL. Further from the point L and drop a perpendiculars LR on line the PM. Note in triangle PRL, angle PRL is angle alpha. As angle NOL and angle RLO are alternate angles and equals to angle alpha. And also angle RLO equals 90. Angle RLP equals angle alpha. Also angle RPL equals 90. Angle RLP equals angle alpha. So the sine of alpha equals RL divided by PL. And the cos of alpha equals PR divided by PL. Now we work out sine alpha plus beta. The sine alpha plus beta equals MP divided by OP equals MR plus RP divided by OP, or equals MR divided by OP plus RP divided by OP. Look at the rectangle MRLN and notice that the side MR equals the side NL. Therefore, the sine alpha plus beta equals NL divided by OP plus RP divided by OP. To solve further, now multiply and divide by OL in the first term and by PL in the second term. So the sine alpha plus beta equals NL divided by OL into OL divided by OP plus PR divided by PL into PL divided by OP. As we know, NL divided by OL equals sine alpha. OL divided by OP equals cos beta. PR divided by PL equals cos alpha. PL divided by OP equals sine beta. Therefore, the sine alpha plus beta equals sine alpha cos beta plus cos alpha sine beta. The sine of sum of two angles alpha and beta is equals to the product of the sine of alpha and cosine of beta plus the product of the cosine of alpha and sine of beta. cosine of sum of angles. To solve cos alpha plus beta, we use same diagram. Cos alpha plus beta is equal to OM divided by OP is equal to ON minus MN divided by OP. Or cos alpha plus beta is equal to ON divided by OP minus MN divided by OP. In the rectangle MRNL side MN is equal to side RL. Therefore cos alpha plus beta is equal to ON divided by OP minus RL divided by OP. Now, multiply and divide by OL in first term and by PL in second term. So cos alpha plus beta is equal to ON divided by OL into OL divided by OP minus RL divided by PL into PL divided by OP. As we know, ON divided by OL is equal to cos alpha. OL divided by OP is equal to cos beta. RL divided by PL is sine alpha and PL divided by OP sine beta. Therefore, cos alpha plus beta is equal to cos alpha into cos beta minus sine alpha into sine beta. The cosine of sum of two angles, alpha and beta, is equal to the product of the cosine of alpha and cosine of beta minus the product of the sine of alpha and sine of beta. Tangent of sum of angles. Now we calculate tangent, or tan alpha plus beta. Tan alpha plus beta is equal to sine alpha plus beta divided by cos alpha plus beta. As we know the sine alpha plus beta and cos of alpha plus beta, we will substitute them here. So tan alpha plus beta is equal to sine alpha cos beta plus cos alpha sine beta overall divided by cos alpha cos beta minus sine a sine beta. Dividing both numerator and denominator by cos alpha cos beta. We get as follows. In numerator of this expression, first term cos beta is cancelled. In second time cos alpha is cancelled. In denominator, first term cos alpha cos beta is cancelled. Finally, tan alpha plus beta is equal to tan alpha plus tan beta divided by 1 minus tan alpha tan beta. The tangent of sum of two angles, alpha and beta, is equal to the sum of tangent of alpha and tangent of beta, overall divided by 1 minus the product of the tangent of alpha and the tangent of beta. Sine, cosine, of difference of angles. To get sine alpha minus beta, replace beta by minus beta in sine alpha plus beta, as we know that sine minus beta equals minus sine beta, and cos minus beta equals cos beta. Therefore, sine alpha minus beta equals sine alpha into cos beta minus cos alpha into sine beta. Cosine of difference of angles. To get cos alpha minus beta, replace beta by minus beta in cos alpha plus beta, as we know that sine minus beta equals minus sine beta and cos minus beta equals cos beta. Therefore, cos alpha minus beta equals cos alpha into cos beta plus sine alpha into sine beta. Tangent or tan of difference of angles. To get tan alpha minus beta, replace beta by minus beta in tan alpha plus beta, as we know that tan minus beta equals minus tan beta. Therefore, tan alpha minus beta equals tan alpha minus tan beta divided by 1 plus tan alpha into tan beta. Summarizing and putting both plus minus angle formulas together for sine, cosine, and tangent. To verify and understand plus-minus formulas, take a very simple case. Let the angle alpha equals 60 degrees and the angle beta equals 30 degrees. So angle alpha plus beta equals 90 degrees and angle alpha minus beta equals 30 degrees. And we know and. Now remember the values of sine, cosine, and tan of 30, 60, and 90 degrees. Verify sine of sum of angles. Put the value of alpha and beta as 60 degree and 30 degree in sine alpha plus beta. Putting the value of sine and cosine of 60 degree and 30 degree, we get sine 90 is equal to 1. Hence, verify the formula. Cosine of sum of angles. Putting the value of alpha and beta as 60 degree and 30 degree in cosine of alpha plus beta. Putting the value of sine and cosine of 60 degree and 30 degree, we get cos 90 degrees equals 0. Hence, verify the formula. Tangent of sum of angles. putting the value of alpha and beta as 60 degree and 30 degree. Tan alpha plus beta. Putting the value of tan of 60 degree and that of 30 degree, we get tan 90 equals infinity, hence verify the formula. We suggest you to verify yourself the difference of angles formula and follow the steps. Sine cosine of double angle. Sine of double angles 2 alpha. To get sine 2 alpha, replace beta by alpha in sine alpha plus beta. Therefore, we get sine 2 alpha equals 2 times sine alpha into cos alpha. The sine of double angles, or 2 alpha, is equals to 2 times the product of the sine of alpha and cosine of alpha. Cosine of double angles 2 alpha. To get cos 2 alpha, replace beta by alpha in cos alpha plus beta. Therefore, we get cos 2 alpha equals cos squared alpha minus sine squared alpha. The cosine of double angles, or 2 alpha, is equals to the square of the cosine of alpha minus the square of the sine of alpha. tangent of double angles 2 alpha. To get tan 2 alpha, replace beta by alpha in tan alpha plus beta. Therefore, we get tan 2 alpha equals 2 times tan alpha divided by 1 minus tan squared alpha. The tangent of double angles, i.e. 2 alpha, is equals to 2 times the tangent of alpha divided by 1 minus the square of the tangent of alpha. Now visual demonstration of double angle formula. Let us see for sine of double angles. Draw an isosceles triangle ABC with sides AB equals AC equals 1 and angle BAC as angle 2 alpha. Drop a perpendicular AD from vertex A and triangle ABC on the side BC. Perpendicular AD will divide the triangle ABC in two equal triangles, triangle ABD and triangle ACD, and angle BAC in two equal angles, angle BAD equals, angle CAD equals, angle alpha. In triangle ABD, angle BAD is alpha, with sides BA equals 1. Sine alpha equals BD divided by BA, or sine alpha equals BD as side BA equals 1. Cos alpha equals AD divided by BA, or cos alpha equals AD as side BA equals 1. Also DC equals BD equals sine alpha. The area of a triangle equals half into base into height. So, the area of triangle ABC equals half into BC into AD equals half into 2 times sine alpha into cos alpha equals sine alpha into cos alpha. Rotate triangle ABC in such a way that the side AB become its base. Now drop a perpendicular CE from vertex C in triangle ABC on side AB. In triangle AEC, angle BAC is 2 alpha with sides AC equals 1. So, sine 2 alpha equals CE by slash AC, or sine alpha equals CE as side AC equals 1, and cos 2 alpha equals AE by slash AC, or cos 2 alpha equals AD as side AC equals 1. So the area of triangle ABC equals half into AB. into CE equals half into 1 times sine 2 alpha equals half sine 2 alpha. As calculator earlier area of a triangle equals sine alpha into cos alpha. Therefore half sine 2 alpha equals sine alpha into cos alpha. Or sine 2 alpha equals 2 times sine alpha into cos alpha. Visual demonstration of double angle formula. For cosine angles, we simply do some calculations. Please follow the steps. Now we learn half angle formulas in simple steps. We start with sine half alpha. Let us revisit cos 2 alpha. Using Pythagoras identities, sine squared alpha plus cos squared alpha equals 1. And cos squared alpha equals 1 minus sine squared alpha. With some simple steps we found 2 times sine squared alpha equals 1 minus cos 2 alpha. Important to note that we let n substitute alpha equals a by 2 or 2 times alpha equals a. Solving some steps, we finally get sine of a by 2 equals plus minus square root of 1 minus cos a whole divided by 2. Now cosine half alpha. Let us revisit cos 2 alpha. Using Pythagoras identities, sine squared alpha plus cos squared alpha equals 1. And sine squared alpha equals 1 minus cos squared alpha. With some simple steps we found 2 times cos squared alpha equals 1 plus cos 2 alpha. Let alpha equals a by 2 or 2 times alpha equals a. Solving some steps, we finally get cosine of a by 2 equals plus minus square root of 1 plus cos a whole divided by 2. Tangent of half angle, a by 2. For tangent of half angle, we suggest you to simply follow steps given here and learn many forms of tan half angle formulas. Using the values of angles as 30 and 60 degrees, you can simply verify double angle formulas and half angle formulas. Thanks for watching. You may leave your suggestion. Please continue to watch our videos.